I want to thank Corby and Ekal and the whole team, but Corby did a great job of taking our presentation and Germanizing it, if you will. So Connor and I are both from Texas, so I've got to talk slower. I can't get rid of my Texas accent, so sorry about that, but I'll try to talk slower so you guys can understand what I'm saying. And I also want to thank Corey and his company, Net Peppers. They've done a phenomenal job for the last several years with our product. Corby could have easily given this presentation. He wanted us to jump on, which I appreciate him inviting us, but his team has become very knowledgeable on our product. So if you guys have any questions after the webinar, please get with Corby, his team, and they'll do a great job of answering and helping you get product and things of that nature. So anyway, so a little bit, we always get the question of, a lot of access points obviously have integrated antennas, which is fine. The question is, when do you use external antennas and why do you want to use it? So today we're going to talk a little bit about why, when, where, and kind of how you use external antennas so that you know kind of the best practices of when you want to use them. And there's a lot of cases where external antennas is by far the best option, and we'll talk a little bit about that. So Connor, good. So a little bit about myself. So you're not seeing double vision here. There's actually two of us. So my name's Carter Burke, and my son Connor, who's an electrical engineer and our main antenna engineer at AccelTex, done a great job for us. We're going to kind of do two different. I'm going to talk a little theory about antennas and why you want to use them and when. And then Connor's going to do the more fun part, which is actually doing a live demo with our antennas within Ekahau and talk about some specific use cases where we've had great success with external antennas, and he'll actually do a live demo, which will be great. So a little bit about our company. I'm not going to spend a lot of time on it. We kind of focus on looking at the radio manufacturers, whether it's Cisco, Aruba, Mist, any of the big line radio manufacturers, and build all the products around it. Everything from antennas, enclosures, mounts, power solutions, power protection, site survey, like battery packs more so, to work for the surveys, and then cable solutions. So we kind of try to do the end to end. We are part of a bigger division of a company, a part of a bigger company called Hubble, which is almost a $5 billion US company. And we're kind of their networking and wireless division. So before I talk about when, why, and how, and when you want to use external antennas, I want to talk about basically what are the two types of antennas. And to keep it simple, there's really two kinds of antennas. Connor, if you want to go to the next slide. There's really two kinds of antennas when you're looking at external antennas. One's omnidirectional and directional, and you'll hear this term all the time. When you're talking about the integrated antennas within an access point, usually it's going to be an omnidirectional antenna, but it's going to be a specific gain, and that's it. You don't have any changes. The reason you're going to want to use, different omnidirectionals or different directionals and mess around with the different gain is because you're trying to cover different areas, and we'll talk more about that. But so talking about the omnidirectional antenna and its pattern, and then we'll talk about the directional is important because, again, it's depending on what you're trying to cover. So the way an omnidirectional antenna works is, this is a great example of an omnidirectional antenna right here. Make sure I keep it close to my body. Is think of it in terms of like a balloon, is the easiest way when you talk about an omnidirectional antenna. So if I connect this antenna to the back of this access point, it's going to have an omnidirectional or a pattern kind of like a balloon. Now what happens is people say, okay, well, I want to have a higher gain omni. What does that mean? So when you think about a higher gain omni, think about taking that balloon and actually, if you look at the picture in the bottom right, squashing it down from the top and the bottom where it kind of starts flattening out, almost like a pancake. And what happens is if you have, let's say, a 2 dBi gain antenna, it's going to be a nice cylindrical pattern. But let's say you go to 4 dBi or 6 dBi or higher gain, what you're basically doing is flattening out that pancake, and you're covering still in a circular pattern, but it's going to be a flatter pattern to maybe cover bigger or longer distances, but it's going to be a much flatter pattern. So what does that mean? I mean, in some applications, you may want to cover, let's say you want to cover a parking lot, which is, this is a great antenna for that as an example. It's going to cover fairly far, but it's not going to be it's going to be squashed down and not be as broad of a pattern because it's a higher gain, but it's designed to cover a large area, like again, maybe a parking lot. So the thing to always remember is as you start, when you think of the gain, is as the gain gets higher, think of it getting flatter. But remember, these radios, these access points only put out so much power. So with that in mind, the only way you get further distances is to manipulate the gain and change the pattern. So you're going to lose something. For example, the higher gain, you're going to have less coverage above and below the antenna, which in some cases may be fine, but just make sure you know which one to use. So that's omnidirectional. The second way you want to look at an antenna is directional. Think of this, as in terms of like a mag light. You guys familiar with this? I'm not going to do the light towards you because I'll probably blind you. But think in terms of a mag light with directional. The way directional antennas work is if you have this mag light on full, where it's open all the way, where it's going to give you your broadest light, if you will. Think about it in terms of a directional antenna. So if it's let's say a 2 dBi directional antenna, it's going to have a very broad pattern, meaning it's going to be a very bright flashlight. As I dial down the flashlight, in this case, like a mag light, it's going to get higher gain. So maybe go to 4 dBi, 6 dBi, 8 dBi, higher gain. It's going to make that pattern more focused. So think in terms of that mag light being dialed down. So the same case with this antenna, if it's a higher gain antenna, it's going to give you a more focused coverage. Connor will talk about in some of his demos in specific applications around warehousing and even manufacturing where that higher gain is important because you're trying to cover very focused areas. But maybe you don't need to cover a focus area. Maybe you're covering a very broad area. You can use a lower gain directional a directional antenna, and that'll allow you to get that, broader pattern. So just think about that, So these are designed, if you look at it from the side, it's designed to propagate the energy out and really not have much energy behind it. So this is really focus coverage. And when we're using external antennas, a lot of the different ways we do it, we do use directional because that's kind of what we're trying to do is get in focused areas. Omnis are very popular with external antennas, but we see a lot of you usually see a lot more variety with the directional because again, you're trying to cover focused areas. So that's the two types of antennas. So with that in mind, we want to look at the why and the when. And I'm not going to translate the German pronunciation because as bad as Matt might have been on it, I'd probably be worse. So this is so Corby, if you get any questions you think we need to bring up during these sections, please stop me and that's fine. So why and when do you want to use an external antenna? So why would you want to use a directional or an omnidirectional? Usually it's when you want that focus coverage. A big application over here in the United States is stadiums or large public venues, soccer stadiums for you guys, or they're actually building a Formula One track and they're putting wireless everywhere. They use a lot of directional antennas because they're trying to get focused coverage throughout these, in this example, like a stadium, because they want to know where the people are going to be and they need to have real good coverage in this one area, but maybe some areas they don't need coverage. So one of the number one reasons you're going to use an external is when you need that focused coverage or focused cells of coverage. Sometimes you're trying to make smaller cells of coverage. It's just to have more throughput. So that focus is very important. Streamline, this is a very important. One of the guys on our team on the call has done quite a few surveys in his career, and he says he can save you, I don't know what the percentage is, but a pretty good percentage of access points and not have to use as many access points by using good antenna design. Because by doing the antenna design, it allows you to focus the coverage, cover where you want to cover, maybe where you don't. And a lot of times you can use less access points. I'm not trying to tell the radio manufacturers we don't want to use less of their access points, but it can save you money and have a more efficient design. Aesthetics is also very important. A lot of times people don't want to see this access point, on the wall. Maybe they want it, above a ceiling tile grid. Maybe they want it hidden in a closet somewhere else. Maybe they think just having a small antenna like this on the outside, and we have, obviously smaller form factors either. So aesthetics is also a very important part of why people use an external. Getting around interference, obviously very important. Again, part of Wi-Fi is you want to cover where you want to cover, but you don't want to cover areas sometimes because of interference. You're trying to actually take the coverage where it's not, going to be in that area. So we use it to get around interference, which is very important. Added physical security, that's very important. A lot of these antennas come with different ways to install them, where you can actually add physical security where people can't take off the product. We see this a lot in education, where you're in schools and you don't want kids to be able to take the product off the ceiling, off the wall. So a lot of times using external antennas, we can bolt them, we can mount them in ways that they can't be taken off the wall. High dense environments, probably next to probably manufacturing and distribution, high dense environments is one of the #1 reasons why we use external antennas. I talked about the stadium or the auditorium type example. If you're going to put, we have some of these stadiums in the US, the university that I went to myself and one of the other gentlemen on the call, it holds 105,000 people, actually 110,000 if we really cram people in. Imagine 110,000 people in a small, it's a big stadium, but still that many people, and trying to get everybody the proper throughput. These high density environments, you have to use focused antennas so you can really get small cells of coverage. That way you can keep all your clients happy. And then long distances from the antenna to the coverage zone. We still, obviously use directional antennas a lot in bridging applications if we're connecting two networks. If you're trying to cover, somebody a little bit further away and you want to, make sure that you add, more a higher gain antenna to the access point, it'll allow you to hear, allow you to send the data further, but also it helps your hearing so that you can hear better, so you can cover longer distances. And a lot of time while we'll use external antennas. So that's kind of the why and when of when you want to do it. Now, Corby, do you want to add anything on that one from a German perspective?
Yes, from this side, let me say 2 sentences in German to this, and then I jump back to your presentation. I have also a chat here. Ja, also die Thematik ist, wann setze ich externe Antennen ein und warum brauche ich sie, ist ein großes Thema. Man hat diese ganzen Thematiken lange Zeit unterschätzt. Früher ist man immer von ausgegangen, viel hilft viel. Das heißt, wenn ich eine Area hatte, eine High-Density-Area, wo ich viel, sage ich mal, Endgeräte habe, die gleichzeitig sehr viel kommunizieren, hat man immer am Anfang der Planung gesagt, ja, da braucht nicht mehr Access Points, bis man drauf gekommen ist, dass das ein Problem ist mit der Capacity. Das Ganze, sage ich mal, kann man heute ohne Probleme mit einer einzigen externen Antenne erschlagen. Dafür gibt es eben extra Antennen dann auch mit hoher Kapazitätsdichte, die das Ganze dann eben auch abfangen können, um zum Beispiel in Veranstaltungsbereichen, dann eben auf kleinen Bereichen eben auch allen Endgeräten die dementsprechende Leistung zur Verfügung zu stellen und eben auch die jeweilige Anbindung zu bringen. Natürlich brauche ich dazu auch immer den passenden Access Point, der natürlich auch diese Kapazität verarbeiten kann und auch zur Verfügung stellen kann. Da möchte ich aber noch nicht vorgreifen. Da kommt jetzt gleich noch mehr von Kader. So, Kader, thank you. I have jumped in here.
Yeah, no, thank you. Okay, Connor, next slide. So, kind of where is the best location? It's funny, I always tease it. It really doesn't matter where you install the access point. It's where you install the external antenna that matters, because that's what's going to be sending out your radio frequency. So, where to is the best location is going to determine a lot of factors. One is what's the coverage requirements. Again, if it's a big open area that's not going to be high density and you just need coverage because people are going to be kind of maybe like it's an open area, like an outdoor area, let's say, and you're going to have people sitting around, but it's not real dense. The coverage requirement's going to be where I can put this maybe on the corner of a building or somewhere and get nice, great coverage. So it's going to depend on what the requirements are. Again, if it's a high dense area or if it's a manufacturing facility that has a bunch of, let's say it's Volkswagen facility and it has a bunch of manufacturing lines and I've got to send the radio frequency around a bunch of metal, that's a coverage requirement that I need to make sure I'm using, probably more of a directional type antenna so that I can get around the obstructions of metal in the manufacturing facility, because the requirements require have coverage for the forklifts and for maybe data collection, but I need to make sure the coverage requirements of the area, I have to take into account what's there. Like, again, it could be manufacturing equipment, if you will. Really the best way to do it, old school. Matt always teases me when I say I'm old school, and I like to hold up props, but I still like to do a good old fashioned AP on a stick site survey. That's going to determine the best place to put your antennas. Obviously, in your mind, you're going to have to think, can I mount it there? Is there a reason why? Maybe it's a historical building and I can't. So that's important to know where you're going to be at to make sure you can determine whether or not you can put the antenna there. I love using the Ecal Pro and the predictive tool. It gives us a lot of good ideas before we go in to do a survey. So we use that all the time to say, okay, what's the predictive tool showing, or the best antenna choices? That's a great place to start, and that's when we go in and do the survey. Again, AP placement's critical. A lot of it, again, it's going to be limited by what the facility may or may not allow. So just make sure you know that when you go into, whether it's a historical building. We have a lot of theme parks in the US, and they care about aesthetics, and they'll say, we want coverage over there, but we don't want to see anything. We want it completely hidden, but we want, perfect coverage. We're like, okay, well, then we have to take into account, where we mount it, how do we hide it, and all that good stuff. So sometimes that's one of the first questions we ask is, where can we mount? Because if they don't care, let's say it's a distribution center, which a lot of times they don't care. They'll say, we don't care where you mount it, we just want good coverage. We're like, great, but it gives us a lot of options. If I go into a hospital and they say, we want it only mounted here, you can't have it in these areas, then that changes how we're going to do everything. So just make sure you know where the placement's going to be doing. But that's why I love all the Ecal tools, because you can use several of them to get you exactly where you want to be. And then obviously you come back later and validate, which is great. How the antenna will be mounted, kind of go to the next slide just because it has pictures. Yeah, so, there's a million ways to mount the product. I brought one mount here to show y'all just a kind of different designs. This is one where you can actually mount the access point and the antenna together, so you can articulate the antenna in a variety of directions and have the access point mounted. So it just depends where you're going to mount. One of the things I will say that I always do is, before you go to any installation, whether you're doing ceiling mount, wall mount, pole, beam, make sure you have all the hardware you need, because it's very common to get to a site and you're like, man, I didn't realize I'm going to have to, mount here. And that's okay. I mean, it's most installations, you have to make a trip to over here we have Home Depots and Lowe's. I don't know exactly what you have in Germany, but I'm sure big hardware stores where you can get the proper mounting, the proper, whatever kind of stuff to mount it. But having really good mounting brackets and ways to mount, like this antenna, you want to mount it, let's say like this, you want to make sure you have a good mounting bracket that maybe mounts to a pole, is very important. And just making sure you take the time to know what the mounting looks like, so when you get to a facility, you have all the necessary hardware. And anything you want to add on that, Corby? Yeah.
On this, a short question inside here. We have received a question on this way. I'm not sure if you can see it. It's a question from David here. It's coming in English, so you can also answer in English when you want.
Yeah, I know Chris and Matt are doing that, and then they can probably answer too on the chat. Yeah. What's the question?
Okay. The question is, can you increase the distance between AP and VGB with a directional antenna at the AP? Because the client still has an omnidirectional antenna.
Between antenna and what?
And the AP. That's the point. When the AP and the client are in a further distance. So
can you increase the distance
maybe we can put it out
of the client talking to the access point?
Yes.
Yeah, the answer is yes. And that's one of the reasons why we use external antennas, because you got to remember, not only does it allow the access point to send the data further or transmit it further, it also it hears better, if that makes sense. I don't know, Corby, over in Germany, do you guys have megaphones? You know what I mean by megaphone?
Yes, for sure.
In the US, we have cheerleaders, people that actually cheer on megaphones for like American football games or sporting events. Y'all have megaphones?
We have megaphones, but not so many cheerleaders. Okay,
well, that's fine. But you know what, I just want to make sure I'm using a term. So think about a megaphone. So I've got this access point. I put, this external antenna on it. Think about putting a megaphone to your mouth and broadcasting with a megaphone. That's what the antenna does, but it also flips it the other way, where the person on the other side can put the megaphone on their ear and hear better. So by doing it, hearing better, transmitting better, you can go longer distances. But remember, you can go longer distances in focused areas. So again, if the more directional antenna, the higher the gain, great, you go further, but you're losing all that side coverage. So just make sure that you're taking that into account in your design, that yeah, you're going to go further, but if you want to cover here and over here, you're going to probably maybe have to have two different antennas, two different access points or whatever.
Great, thank you for your explanation here.
Yes, sir. Anything else, or okay, Connor, if you want to go to the next slide. I wanted to take a couple seconds just to talk about this, because I've been in the industry for 24 years now, believe it or not. Long time. I didn't have gray hair when I started in this place, but probably the number one external antenna issue I've had in my career, where an installation has had a problem, is not that the antenna was not picked perfectly and great access point. It's just the connectors didn't match. So one thing I want to make sure you take into account, and this is important when you're looking at external antennas. One, I would always say, if you're going to use an external antenna, if you can, get a sample and test it physically. That way you know it works for your application. Don't go buy 100 antennas you've not tested live. But one of the things to take into account is, again, if you're using an access point, make sure you know what the connector is on the access point and how many connectors are on the access point. And the one thing that's inconsistent about Wi-Fi that kind of drives me crazy is the connectors are different. Cisco will use RPTNC. They use N-Style in some of their products. Mist will use RPSMA, and I think they even have some older stuff that has like N-Style, but they use different connectors. Aruba the same way. Making sure you know which connector, like for example, on the end of this, if you can see this, is a little tiny RPSMA connector. See how small they are. But you also, I wanted to show this is an N-Style. You can see how much bigger that connector is. So depending on what the radio is, make sure you take the time to know the connector and how many connector ports. Otherwise, I'm just telling you, you're going to have a problem when you get out to the site and you're going to be like, these things don't connect together. Also, if you're going to add stuff like cable extensions, or if you're going to add lightning protection, which is very important if you're going to be outdoors, make sure all those connectors match up. I still get a piece of paper and I write out all the connections to make sure they all match together, to make sure when I get to the site, it works properly. Another thing to keep in mind, some of the newer stuff coming out may have specialty connectors, like this is a dart connector. So just again, make sure you take into account what the connector is and what access point. And that's something where we can help you. Corby and his team can help you. If you say, okay, I've got this particular access point, they can quickly say, okay, based on that, we know what antennas will work, and if you have any, like I said, a lightning protection, all that, you can keep it all together. But it'll save you a lot of trouble to take a little time to make sure you do that. Anyway, so go to the next slide. So I'm going to shift gears a little bit now, and I'm going to turn it over, let Connor kind of close us out with some of the use cases that we have, that we've seen a lot of external antenna use, as well as he'll go over a live demo and kind of show how our stuff works and why external antennas are really, really helpful in certain situations. So Connor, I'll turn it over to you.
Yeah, thanks.
Corby, any questions before I turn it over to Connor? Are we good?
Yes, we have one question, but let us show into the demo. I think the question will be then more clear, and then we can go after your demo to this question.
Perfect. Sounds good. So I'm going to go over 3 of the more common use cases. Obviously, there's many other uses that you can use with external antennas, but we're going to go through a warehouse, a large parking lot, and a large public venue. So beginning with the warehouse, we see a lot of need for having a very directional antenna that goes up and down the warehouse aisles, because you can tell from the 2 images, depending on what inventory level or what your inventory actually is, can drastically affect how the antenna propagates, because it either can or can't go through that product, and it will attenuate the signal going through it or not attenuate it, and then you have bleed over into adjacent aisles. So you come to the point where you need a directional antenna that doesn't just propagate like an Omni, because you can see here in a warehouse, just a typical warehouse, and for y'all's reference, these are 90-meter long aisles, and the AP is mounted at 15 meters. The Omni is kind of being blocked off because these are full shelves, and it's only going about a third of the entire aisle. So you're not getting a whole lot of coverage. You're going to have to use 3 of these APs per aisle if you wanted to use the internal Omnis. However, if you were to go and pick an external AP and mount it with our warehouse antenna, say, oh, that one was already set up. So you would go in here, type in our 13 dBi warehouse antenna, which is the part number there, put it on the ceiling, put it at the same 15 meters, the same power level. You can tell that this covers your entire aisle with a single AP, and you're not having to worry about any bleed over to the other aisles, because by itself, it's still just the propagation that goes only up and down the aisles, versus the Omni, where you can tell that it's an omnidirectional, which this is kind of high, so you can't really see that as well anyway. But and then beyond that, we typically recommend that you mount to the center of the aisle, because that gives you the best coverage over the entire length, and you don't have to worry about any interference from say if you had a forklift on this end and your AP is mounted here, which I can replicate that by taking that same antenna even and putting it onto the wall. Yep, dropping it down to, say, 4 meters. So you're still being able to shoot down the aisle, and this is still, went too far, went into the wall. You're still able to shoot down your aisle this way. But if you were to get a forklift on this end and you're trying to come from the other end to get signal, you're not going to be able to see it as well, because you're going through that forklift or other warehouse employee. So the best option is to typically mount it from the ceiling using our co-location mount. Another simple use case. So in this case, we're using and comparing a typical outdoor AP that has the internal Omnis versus an indoor AP with our external 4.6 Omni that Carter showed off. So you can see that the coverage is basically the same. And the reason why we see people use our antenna with the indoor Omni is because, one, right now, supply chain, a lot of people can't even get the outdoor rated APs. So you're forced to use an indoor AP. And in that case, you can keep your indoor AP inside and run the cabling from the antenna through the wall to the antenna that is then mounted outdoors. So that kind of protects your AP still, keeps it away from all the weather, any external threats to it, but you still get to propagate your Wi-Fi outside. And then the other reason is a lot of times the cost of an outdoor weather rated AP is a lot higher than the indoor AP and an antenna. So we see the uses for it for both those reasons, mainly just kind of weighing the options of, is it available and is it really necessary if I can use an indoor AP and kind of save some costs there. So that's the main reason why we see like in a parking lot location, our Omni being used instead of the internal Omni on an outdoor rated AP. And then the final general use case that we're going to go over is a stadium or just large public venues in general. So in this case, you can see that we have a lot of our enclosures and mounts being used to also hide the AP and antenna. So aesthetics are really big for a lot of these locations. So we can disguise the AP and antenna combo as a section number or put it in the entrances to the sections. And we even have handrail antennas that mount directly to the handrail so that they're out of the way, but you still get propagation going to the left and the right of the handrail. So that's a unique solution that we have that is popular because it still propagates both ways. And then we'll pull up the example for a large public venue. So here's a typical, and I want to make sure y'all can hear me because sometimes my computer doesn't like me doing this and presenting. There we go. Just a typical basketball arena that you can see here. And this is also being used in this case for concerts or dinners. So you have to be able to cover the court actually. But the issue that you run into there is the ceiling above it is 20, 30 meters high because you're in a large court that has to be high enough for people to be able to shoot basketballs and not hit the Jumbotron, for instance. So what you run into is that you need a very high gain antenna. This is our 30 by 30, which is also a 13 dBi. And I can grab here. And you can see that these are mounted 30 meters high, but you're still keeping the coverage nice and isolated to the court primarily. And even at that higher distance, and this is designed to neg 65. So if you even drop it to 67, you'll get a little bit better coverage. But the benefit of using these high gain, high directional antennas of the 30 by 30 is that you're able to get this many into a space without there being the co-channel interference. Say, for instance, if we grabbed 2 APs of the same channel here, there's a barely bit of touch there on the neg 67 so that they keep their cells isolated and you can still keep your network health good without having interference from the other APs on the same SSID, but they're not overlapping each other. And that was it for the demos. I just wanted to go through some quick general use cases. So now we can start going over any questions y'all have.
Thank you. Thank you, Connor. Thank you, Carter. And thank you also to the rest of AccelTex team who are here to answer questions in our presentation here. For now, we have answered all the questions what coming in by text and in the chat and in the questionnaire. We have received one quick question now. What antennas are used for the stadium? So maybe you can explain some things here.
So here we're using our high density, our outdoor high density patch, which is our 1312. So this is a 30 by 30 degree, 13 dBi dual polarized patch antenna. So this is a larger high gain patch that's used for farther distances and keeping nice isolated cells. So that's what we're using here in the center of the public venue.
Great. And another question is, which power level is recommended to set when using external antennas?
That's kind of depending on your use. In the past, also a big consideration was you had to keep the power level close to your client power level. Otherwise, you got a power mismatch. But in the past couple of years and definitely going into the future, that has become less of an issue. You're able to actually turn the power up more on your access points without there being any mismatch. They just have better technology inside of them to manage that. So typically the 14 dBm on the 5 gigahertz, you can go a little bit higher than that, probably to 17 or 18. But beyond that, you start to have to really be cautious of staying within your local EIRP laws. Because if you use a higher gain antenna, you can exceed those laws if you were to crank up the power all the way. So once you start getting into the higher powers of your AP, you just have to be more vigilant.
Great, thank you. There's some question I didn't know if you can answer on it. It's going about Cisco client link beamforming, serious improvement or more marketing. I'm not sure if you want to ask here or give.
Yeah, we probably will stay. We'll probably want to stay away, Corby, from that.
Probably, yeah.
They're a good partner of ours. We'll leave it at that.
Yeah. So from this side, so no more questions, and we running out in time. So really thank you, Kader. Really thank you, Connor. Really thank you to Chris and Matthew, who are in the back of our team here and answer in the chat. If you have any questions.